At 0241, UTC NASA's Goldstone planetary radar returned a second spiky echo, just off the lunar limb, an off-target streak that should not exist, and the tag attached to that echo was 3I Atlas. The moon hangs still beneath us as telescopes pivot worldwide to confirm the reading. Normally, distance is a calm problem. You track a faint point over hours, fit its arc, and the math settles into place. But tonight, NASA's infrared eyes, ESA's optical arrays, and a chorus of amateur observatories measure parallax so large it refuses to be an illusion. Parallax is simple geometry, the apparent shift of an object against background stars as you look from different vantage points. The shift they see is the kind you get only when something is very, very close. Control rooms flare awake as a second round of tracking begins. Usually a trajectory locks down with each new observation. Here, it loosens. The route predicted yesterday unravels under today's data, and the object wanders off the rails by subtle, stubborn increments. Spectral measurements tell us what it is made of, or at least what sunlight reveals: ices, dust, organics. But the spectrum is quiet, almost featureless, leaving little to blame for extra pushes or drags. Scientists huddle over whiteboards as the possibility dawns. Psi Atlas may be skimming the Earth-Moon system. Normally that phrase belongs to asteroids born here, not travelers between the stars. So committees form in hours, not weeks, to reassess impact odds, to model dust lofted from the lunar surface, to ask whether orbiters might need to adjust their paths. Across the globe, phones and fibers light up. CNSA offers lunar telemetry. JAXA reactivates rapid response scheduling. ESA corralled its deep space antennas, and NASA folds in navigation teams. We have done this before Oumuamua, then Borisov, but not with a visitor flirting with the moon. This feels more like Shoemaker-Levy 9's urgency, translated from Jupiter to our backyard. Theorists split into camps. Some argue an extreme mass to area ratio, thin, broad, unusually sensitive to sunlight, could explain the nudge echoing the radiation pressure debates of Oumuamua. Others point to faint anisotropic outgassing that hides in bland spectra. A few float three-body choreography, a hyperbolic interstellar path briefly twisted by Earth and Moon into a deceptive near graze. Uncertainty for now rules. With the geometry poor and the phase angle harsh, every new image sharpens the object and blurs the future. Why would an interstellar object behave like this? What hidden mechanism could produce such a transition at the doorstep of our own satellite? And yet in the quiet between updates, a larger thought settles moments like this, remind us that the universe is not obliged to be simple when it comes close. A coronagraph blocks a blinding source to reveal what hides nearby. Tonight, the moon itself becomes the mask, and the truth steps into view. The latest range solutions agree on one unsettling point. 3I Atlas has slipped inside the moon's sphere of influence. First came the alignment. As the moon slid across the sky, telescopes from Hawaii to the Canary Islands used its dark limb as a moving mask, isolating a dim speck that refused to sit where models predicted. Normally, an interstellar visitor at this geometry would appear just beyond the moon's, reach its range broad but stable. This time, the triangulated parallax snapped tight. 3I Atlas had dipped inside the moon's sphere of influence. Then came the pings. Goldstone in California and DSS-43 near Canberra sent radar chirps toward the predicted track. Under ordinary circumstances, echoes from something truly interplanetary are too faint or delayed by many seconds. Instead, a whisper came back with a near lunar delay, and the Doppler spread hinted at a fast skimming pass. Let us break this down. A coronagraph works by blocking a bright source so hidden neighbors emerge here. The moon did the blocking, and parallax between continents measured distance the way your two eyes judge depth. If the angles change a lot across Earth, the object is close. If they barely change, it is far. 3I Atlas jumped between frames, an unmistakable sign of proximity. Across space agencies, the checklists lit up. NASA tasked Lunar Reconnaissance Orbiter to watch the plasma wake. ESA slewed. Its optical ground station JAXA extended. Observing windows, CNSA shared change network data. Amateur astronomers stacked rapid frames through the lunar glare. Some teams argued Earth's gravity had focused the inbound path toward the moon. Others doubted the readings entirely pointing to scattered light and limb diffraction. Brightness behavior added fuel. Normally, comets brighten predictably as sunlight warms their volatile ices. 2I Borisov performed exactly that script. 3I Atlas brightened, then plateaued as it entered the moon's shadowed magnetotail, where charged dust behaves differently. Solar physicists were divided. Was electric charging not ice driving the show? Trajectory Fits told a stranger story. A hyperbolic visitor should ignore small bodies at interstellar speeds. The moon is a pebble in a river. Yet solutions converged on a grazing passage inside the lunar hill sphere. No capture, but a measurable deflection. That matters. It lets scientists probe gravity radiation pressure and the object's area to mass ratio, an echo of the Oumuamua puzzle. Spectral measurements added nuance. A featureless red slope suggested a dry space-weathered surface, while a brief glow in sodium lines common in the moon's tenuous exosphere hinted at sputtered atoms in the lunar wake. Some teams saw carbon-rich compounds. Others could not reproduce the signal. The debate sharpened, not softened, and here is where things take an unexpected turn. If an interstellar shard can brush a moon's gravitational neighborhood, how many such flybys have we simply missed? What hidden mechanism could produce such a precise thread through the Earth-Moon system mere chance, or the statistics of a crowded galaxy? Moments like this remind us how little we truly understand. But this was only the beginning. A sudden flash ripples across the moon's night side, caught by amateur monitors in Spain and Japan, and flagged by NASA's meteoroid office within minutes. Normally, these flashes come from garden-variety meteoroids that pepper the lunar surface with tiny silent fireworks. But this one arrives exactly as 3I Atlas is threading the Earth-Moon plane. Scientists interpret the timing as more than coincidence, and the deeper implication is unsettling. An interstellar shard may have skimmed our cosmic backyard. A second clue appears when lunar orbiters report a whisper of extra gas above the impact region, a transient breath in the moon's thin exosphere. Usually, micrometeoroid hits release sodium and potassium in familiar ratios. Here, spectral measurements tell us there is an unexpected hint of carbon-bearing fragments, the kind we see around volatile, rich bodies. Some teams argued this pointed to a fragile interstellar crumb, while others doubted the readings entirely, warning that instrument noise can impersonate chemistry at the edge of detection. A faint asymmetry shows up next in coronagraph images from SOHO and stereo, a dusty halo offset from the predicted track. A coronagraph works by blocking the sun's glare to reveal faint light near it, and normally comets brighten in a predictable curve as sunlight and heat drive outgassing. This halo should not be there if 3I Atlas were far away and solar physicists were divided. Was it a fragment shedding dust or a background feature in a crowded solar wind? A coordinated radar experiment follows with Goldstone pinging and green bank listening, joined by ESA dishes and a CNSA tracking station. Usually interplanetary objects are too small and too distant for a clean echo, yet the teams record a fleeting return that lines up with a reflection near the lunar limb. If true, the geometry implies 3I Atlas, or a piece of it passed much closer than the early orbit fits suggested. Orbit modelers from JAXA to ESA reprocess everything integrating tiny non-gravitational forces from jets and dust drag. What should be a smooth trajectory becomes a thread pulled by lunar gravity and a subtle push from outgassing echoing the mystery of Oumuamua's gentle acceleration. Why would an interstellar object behave like this, slipping through a gravitational keyhole so narrow we almost missed it? Deep space probes seize the moment solar orbiter tweaks, pointing to grab background dust profiles. Bepi Colombo hunts for sodium tails. The Vera Rubin test array and a network of small telescopes across 3 continents chase the light curve. Some teams argue this points to a population of weak, fluffy travelers that only brighten when jolted. Others warn we might be reading patterns into noise. The larger meaning lands quietly. Our moon, usually a passive witness, may have recorded the brush of a traveler from another star, and that touch reveals how porous our neighborhood really is. Moments like this remind us how little we truly understand and how much the cosmos still hides in plain sight. And then something even stranger emerged. An unexpected chain of lunar flashes ripples across the dark side of the moon, caught first by amateur telescopes in Spain and Japan, and then flagged by NASA's meteoroid monitoring team. Normally, impact flashes appear as random pinpricks from sporadic interplanetary dust scattered in time and place. This time, they march in a loose line, clustered in minutes, tracing a common direction. Scientists read the pattern as a moving sheet of grains cutting through cislunar space. And here is where things take an unexpected turn. A coordinated alert from ESA's Neliota project confirms the geometry, triangulating the radiance back toward the predicted track of 3I Atlas, but shifted closer to Earth than models allowed. Usually meteors point to known showers, or to the general background. In this case, the radiant aligns with an interstellar visitor, implying its debris crossed the Earth-Moon corridor. Teams at NASA, ESA, and JAXA push out rapid orbit updates. Chinese analysts at CNSA caution that a coincident swarm could mimic the effect. To understand why this matters, we need to look at the moon as a detector. Its airless surface turns invisible dust into visible flashes. A subtle brightening then blooms along the lunar limb, recorded independently by LRO's ultraviolet spectrograph and India's Chandrayaan-2 mass spectrometer. Normally, the moon's exosphere, an ultra-thin veil of atoms, ebbs and flows gently. This spike in sodium and potassium lines points to fresh impacts liberating surface atoms. Spectral measurements tell us not just that something hit, but what it stirred up. If 3I Atlas shed a dust sheet dense enough to light the moon, it was not far away. At the same time, coronagraphs on SOHO and stereo pick up a faint streak near Earth's line of sight. A coronagraph works by blocking the sun's glare to reveal delicate halos and dust structures. Solar physicists were divided. Some saw a debris ribbon consistent with an interstellar coma brushing past. Others doubted the readings, entirely wary of instrumental ghosts and zodiacal light. A global refit of the trajectory follows pulling 3I Atlas inward by a precious margin, using the moon as a giant screen. Normally, parallax from Earth-based telescopes sets the distance. Here, the timing of lunar impacts becomes a yardstick, a rare natural calibration. Some teams argued this pointed to an unusually fragile, actively shedding object. Others insisted we were reading patterns into noise. Why would an interstellar object behave like this? The larger implication settles slowly. Our interplanetary backyard is porous enough that sands from another star can sift through and leave fingerprints on our nearest neighbor. This echoes the mystery of Oumuamua's subtle push and Borisov's cometary grace, yet it is more intimate, a trace on the moon itself. Moments like this remind us how little we truly understand. And then, with the models still warm, what happened next surprised everyone. The first hint arrived at lunar nightfall, when small spectrographs in Hawaii, La Palma, and South Africa caught the moon's faint sodium glow surging. Normally, that ghostly tail brightens during familiar meteor showers as micrometeoroids knock atoms off the surface. This spike came off schedule and from a direction aligned with 3I Atlas' predicted approach. Scientists read it as a dust handshake from interstellar space. And here is where things take an unexpected turn. The models only fit if the dust sheet is already threading the Earth-Moon corridor. A sudden flash on the moon's dark limb confirmed the suspicion. NASA's impact flash monitors, ESA's Neliota, and amateur telescopes in Chile and Namibia recorded a blue-tinted double pulse. Impact flashes usually follow a predictable brightness curve, shaped by the speed and size of a meteoroid. This one rose too fast and faded in 2 quick breaths. Photometry and color told a story of hypervelocity particles and unusual volatiles, and the incoming direction was skewed in a way that only makes sense if the source stream is much closer than orbit solutions had assumed. A rapid response slew by NASA's Lunar Reconnaissance Orbiter pinned the new crater, and Diviner watched it cool through the lunar night. Normally, the cooling curve maps neatly to known meteoroid energies. Here the heat bled away, as if the surface had been shocked harder than expected. That mismatch nudged dynamicists toward a revision. 3I Atlas debris was not just passing by, it was brushing the moon's immediate environment. Chandrayaan-2's exosphere sensor added a whisper of chemistry. It sniffed a brief uptick in sodium and faint carbon-bearing fragments. Spectral measurements tell us about both composition and source. In this case, the ratios did not match the usual signatures of Leonids or Geminids. Some teams argued this pointed to exotic dust grains. Others cautioned that calibration drifts can mimic novelty. Solar observatories offered a critical control. A coronagraph works by blocking the sun to reveal faint structures around it. SOHO Stereo and Solar Orbiter saw no corresponding dust surge near the sun. If this were a solar proximate outburst, it should have been obvious. The quiet coronagraphs strengthened a bolder idea the anomaly was local to Earth-Moon space. A multi-continent parallax campaign then pressed the geometry. By measuring tiny shifts in 3I Atlas against the Moon's rim from distant observatories, astronomers triangulated its path. Normally, the shift is small and tidy. This time it was larger and stubborn, pulling the solution inward by a few million kilometers. To understand why this matters, we need to look at how distance drives everything: brightness, dust density, and the odds of interaction. Reactions rippled across the community. Solar physicists were divided. Some teams argued this was the first clear case of an interstellar debris sheet threading cis-lunar space. Others doubted the readings entirely, calling for more lab cross-checks. NASA and ESA scheduled additional LRO and ground campaigns. CNSA routed extra downlink from change instruments. JAXA's SLIM team squeezed twilight observations from a tired lander, and amateurs kept the watch frame by frame. Why would an interstellar object behave like this? What hidden mechanism could produce such a transition from distant visitor to close-in dustfall? It echoes the mystery of Oumuamua's subtle push and Borisov's straightforward coma, yet feels more intimate the cosmos, leaving a calling card on our own moon. Moments like this remind us how little we truly understand. And then something even stranger emerged. First came the pattern on the moon. Fresh-peppered microcraters lit up in LRO night-side flash data and in change far-side seismics, all pointing back to a single radiant near Earth's leading limb. Normally, interstellar dust just whispers through the system, its flux too thin to noticeably paint the lunar surface. This was different, a coordinated dustfall, like a fine directional ash. Scientists read it as a sign that 3I Atlas had not just flown by, it had shed material into cislunar space. And here is where things take an unexpected turn. Then the coronagraphs noticed a wrong-way tail. A coronagraph works by hiding the sun's bright disk so faint, structures around it, like comet tails, become visible. Usually those tails point away from the sun, driven by photon pressure and the solar wind. But ESA's Solar Orbiter, NASA's SOHO, and amateur solar observers saw a filament aligned toward the Earth-Moon line. Some teams argued this pointed to dust grains being steered by magnetic fields and radiation pressure into a narrow stream. Others doubted the readings entirely, suspecting processing artifacts. To understand why this matters, we need to look at where that stream went. Spectra told a stranger story. Subaru and the VLT caught faint gas emission familiar cyanogen and carbon bands, but with sodium lines stronger than expected and an unusual isotopic fingerprint hinting at a colder birth cloud. Spectral measurements tell us what atoms and molecules are present by their light barcodes. Normally, short-period comets mirror our own solar mix. This one did not. Solar physicists were divided. Was it genuine interstellar chemistry or contamination from the moon's delicate exosphere stirred by impacts? Trajectory solutions suddenly converged on a shockingly tight pass. Using the timing of lunar flashes like Beacon's teams at JPL and ESA's ESOC refined the orbit and found 3I Atlas had skimmed the outer edge of the Earth-Moon system. Gravitational focusing mass bending the paths of passing particles would have intensified dust onto the moon. Normally, such focusing is subtle here, The geometry amplified it. The global response was immediate. NASA tasked LRO for repeat passes. CNSA pointed change assets at the fresh sites. JAXA's Hisaki scanned for exospheric sodium, Parker Solar Probe, and Bepi Colombo reported brief dust spikes. Amateur meteor cameras from Chile to Namibia logged a soft, slow radiant. Some teams argued this proved 3i Atlas was much closer than first modeled. Others urged caution, reminding us how easily coincidence can masquerade as causality. History offered echoes, but no match. Oumuamua nudged itself without a visible coma. Borisov behaved like a textbook comet. 3i Atlas left fingerprints on our nearest neighbor. Why would an interstellar object behave like this? And so we asked a harder question. If the moon can become our interstellar dust detector, what else can our backyard reveal? Let us break this down closer. Passes may be rarer than comets, but richer in clues, and they challenge us to build rapid response networks that link sky, sun, and surface. Moments like this remind us how little we truly understand. What happened next surprised everyone. A sudden brightening rippled across the moon's faint sodium glow, and telescopes from Arizona to Atacama called it in within the same hour. Normally, this exosphere flickers during familiar meteor showers, when comet dust smacks the regolith and frees sodium atoms that sunlight pushes into a long, invisible tail. But this surge came off-season from an odd radiant, and with a Doppler shift that screamed high speed. Spectral measurements tell us how fast atoms are moving by how their colors slide. Here the lines were broadened and shifted beyond typical lunar meteoroid impacts. Scientists interpreted it as a dust pulse, and the direction traced straight back toward 3i Atlas. The implication was stark interstellar debris had brushed the Earth-Moon neighborhood. An hour later, ESA's solar orbiter caught a thin streamer in its coronagraph. A coronagraph works by hiding the sun's glare so faint, structures dust plasma comet tails become visible. Normally, the position angle of a tail matches the predicted ephemeris of its source. Here, the streamer sat a few degrees off the forecast, a geometric nudge that only makes sense if the source was closer than we thought. Solar physicists were divided. Some chalked it up to a gusty solar wind pushing dust sideways. Comet dynamicists countered that the offset was too coherent, too persistent, more like a nearby filament sweeping past. Confirmation arrived from orbit. NASA's LRO saw the lunar dayglow spike JAXA's Hisaki, tuned for tenuous gases, recorded the same surge China's change relay, pointed out fresh thermal anomalies, consistent with micro-impacts on the nightside terminator. Spectral measurements tell us composition by comparing fingerprints of light. The sodium and potassium ratios looked normal, but the velocity distribution did not hyperbolic, not bound. Some teams argued this pointed to a fragmenting sheath around 3i Atlas. Others doubted the readings entirely, noting a recent coronal mass ejection that could have sputtered atoms off the surface. Orbit solvers from NASA, ESA, and amateur networks fed in the new angles, and the fit tightened uncomfortably. 3i Atlas, or at least its dust, had threaded the Earth-Moon system closer than early solutions allowed. This echoes the mystery of Oumuamua, where forces beyond gravity nudged the path. Why would an interstellar object shed dust in pulses that masquerade as solar weather? What hidden mechanism could produce such a transition so near our doorstep? Moments like this remind us how little we truly understand. But this was only the beginning. A flicker rippled across the moon's dark plains, and then another. Observers from Greece to Arizona logged a chain of tiny impact flashes, stepping across the night side in a moving arc. Normally, these glints arrive randomly, the signature of sporadic meteoroids. This was different, a coherent front timed like beads on a string. Triangulation from multi-continent telescope arrays traced the stream's path, not to distant space, but grazing the Earth-Moon system itself. And here is where things take an unexpected turn. It placed 3i Atlas much closer than anyone thought. A faint haze then rose above the lunar horizon. Lunar orbiters reported a transient brightening along the terminator, a whisper of dust lofted higher than it should be on an airless world. Normally, the moon's exosphere is so thin it is almost a rumor. This looked like a brief breathing veil. Scientists at NASA and Kerry compared LRO and Danuri data, and argued it matched a passing plume material shed by 3I Atlas, swept by solar light, and drawn through the lunar neighborhood. Coronagraphs added a new angle. A coronagraph works by hiding the sun's disk to reveal faint structures that would otherwise be drowned in glare. SOHO and Stereo saw a diffuse fan, but its axis did not center neatly on the Sun-Parker solar probes. Cameras caught forward, scattered light aligned with the Earth-Moon line. Normally, dust tails point away from the sun. Here, geometry betrayed proximity. Solar physicists were divided. Some teams argued this pointed to a solar wind eddy focusing dust toward us. Others said the alignment demanded jets from 3I Atlas themselves. Spectral measurements tell us what light alone cannot. Keck, VLT, and ALMA sniffed an unusual mix, volatile-rich signatures, carbon monoxide traces of nitrogen, bearing ices riding on bright, fine grains. Normally, comets brighten in a predictable curve as sunlight warms their surfaces. This one pulsed its output, yawing with a spin or a sudden phase change, like frost turning to gas in bursts. Why would an interstellar object behave like this? What hidden mechanism could produce such a transition so close to our doorstep? The timing of the lunar flashes provided the clincher. Using parallax, the small shift in apparent position from different vantage points, teams at ESA and JAXA recalculated the distance to the stream. Early solutions placed it comfortably far. The new fit swept it inward, threading the Earth-Moon system. Some groups proposed fragmentation, a shed sheet of particles. Others doubted the readings entirely until amateur astronomers reproduced the pattern night after night. History offered an echo. We have not seen something like this since Oumuamua made gravity share the stage with subtle forces, and not since great meteor storms strobing the lunar night side have we watched a stream remake the local sky, but an interstellar source carving through our backyard that is new. To understand why this matters, we need to look at more than orbits. This is about contact. Interstellar objects may not just pass by, they can touch worlds, seed exospheres, and rewrite trajectories with chemistry as much as with mass. Moments like this remind us how little we truly understand. 3I Atlas was closer than we thought in kilometers. Yes, but also in meaning. It reached across the gulf, scattered a handful of dust on the moon, and left us with a question that will guide the next decade. If the space between stars is sending us messengers, what stories are we still missing in the faint light between the flashes?